Hi guys. Hi guys. Okay, I'm waiting on two more, right? Let's see. Geometry Sunday, no one is coming. Good. Geometry Friday. Yeah, it's okay, pa. நீங்க ஆறீங்கப்பா. ஆறீங்க. Hi guys. Yes, pa, sure. Waiting on one more student. So please give me another one. Keep going. Okay, so I don't see her coming. Let's go ahead. So coming to three topics, right? These are the three topics that I want to touch upon. One is constructions probability. Number two, number three, spherical versus Euclidean geometry. Dia, please video on. Johan, can we get started? Okay, so Let me know, guys, which one do you want me to go over first? These are the three topics which I know that you guys are not familiar with. Okay, other than these three topics, guys, do you know how to look at the TICS benchmarks? I really want inputs from you. Quick, 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 so we do it nicely. Do you know how to refer to the TICS benchmarks? Guys, do you know?
Yes.
I don't think so.
You don't think so? Okay, that's great. Okay, now then I will show you, right? So this is where you go, share, Chrome maybe. Are you seeing middle school, high school?
Yeah.
Oh my god, what's going on, guys? Chrome completely closed. Hold on, something happened. I don't know what happened. Just a minute, guys. Wait, I was sharing, Chrome completely closed. Wait. Oh, because too many windows were open. Okay, I got it. Okay. Let me close off several of the windows. So you should be able to see geometry. I'm going to share my screen. So first let's go over the benchmarks that we have that you need to go through. Make sure that you're good with that. Okay, so Chrome, I don't see it at all. Why am I not able to share that? 1 second, guys. I want to share this. Let me share my desktop directly. You see my desktop, right? You're able to see this window? Okay, good. So now it will start with this. So coordinate and transformation geometry. Have you gone through this, all of you? So are there topics that you're not familiar with, Johan? Huh?
I think I'm good with all this.
Good with all of this? Okay. How about you? Can I send this to you all in the chat now?
That would be helpful.
Yeah, but note it down, guys. If I send it to you in chat, I send it out in chat. Okay, these are the benchmarks that will be tested. Okay. So you should be able to, meaning you should be able to answer each of the questions, and here you are going to go over, and if you have any doubts, you are going to come back. Make sense? In this, from my filtration, what I have done is, okay, I don't think we have covered this one. Difference between Euclidean, it's a very small thing, but then you should know, because including parallel lines and some of angles in a triangle. Yes, some of the angles in a triangle in Euclidean geometry is 180 degrees, right? In spherical geometry, it's greater than 180 degrees. Okay, coming to parallel lines, so we'll go over it. Okay, it's a small subunit, but then it is quite important. Okay, that is one. And what I have not done much about is this piece. The last piece is there. And then one more thing which I have not done is constructions. Did I give you the construction things that you need to go over? Meaning, yep, this one. Have you gone over this? Yes, no. Should I drop it in the classroom? You have to let me know, guys.
I think
Basically, see, this particular one we have done in class. I have not done construction parallel through a point, parallel line construction, or what else. I have not done construction of construct angles. They won't ask. Okay, like that they did not ask the year before. Okay, But the same thing I told the kids, they will not ask construction and geometry just because they did not ask the previous year. Last year I was bitten, in the sense a kid got 2 questions on constructions. You see, I said they don't have to study last year, but that was not the case. They had asked 2 questions overall. Okay, so the kid managed to do 1, I think, or 2, but whatever it is, meaning constructions, it might be it might be a single choice question, but you'll have to know constructions. One way is so this is one topic I have not touched upon. What you need to know is not all of this. See guys, this is not Texas standards. Please understand that. What you need to know is whatever is given here. You see, one second, I'll show you what you need to know. See, this is the problem. They have not elaborated on it, but do you see? Construct congruent segments, congruent angles, a segment bisector, angle bisector, perpendicular lines, perpendicular bisector of a line segment, line parallel to a given point, not through point not on the line. So basically, construct congruent segment. They'll give you this segment. How do you draw okay, let's take this. Okay, let's take this. I'll copy down. I'll show most of this today, but you have to follow it with me, guys. You have to be quick and you have to follow it with me. Okay, so I'll give you that. I'll give you the link to go over, meaning I'll give you the link where you can draw. You don't need any protractor or anything, but you need to draw with me, otherwise it's not going to work. Okay, I forgot the website even. I think it's geometry text pad. Maths pad, correct. So this one. You have this website I've given you earlier, right? We did discuss in one of the classes, right? Yes, no, please answer, guys. Johan, I'm not able to hear you, Johan.
Yeah.
Okay, so basically construction of a line segment, copying a segment we did, right? We took one of this. Okay, suppose you denote them as A and B. What did we do here? Basically we took this compass, plotted it here. See, this is unlocked, so measure this, lock it, then draw another big line segment, bring your compass here. Now what do? Touch on the black color thing and draw an arc. See, now you name it as, move the compass out, name it as CD and say the CD line segment. You'll say CD is congruent to AB. That's it. This is drawing congruent line segments. Make sense? Yeah. Now copying an angle is how? I don't think they'll ask, but if they ask, you should be able to answer for me, that's all. So here, okay, let's say I have this angle, right? If I ask you to copy the angle, what you would do? Copying the angle is pretty easy too. So what you do, let me show you. A, B, C. Okay, now I'll draw A dash. This is what I'm going to draw, B dash. I draw a line segment. I have to copy the angle, right? So what do? First I take the compass. Okay, place the compass here. Then draw arc. See, the problem is for drawing the arc, you should be able to touch that black color thing on top. Sorry guys, give me a minute. I'm going to clear everything. I'm going to draw the angle here. This is what I want to copy. Okay, now I'm going to copy the angle here. So what I'll do, I'll bring the compass here. I'll draw an arc using this black color thing. If you touch only, it will draw the arc for you. On top, you have to here when you draw in this textpad.co.uk construction, you want the link. Dia does not have the link, right?
No, I don't think I do.
Please have, if you want to draw and see, go here, draw it and see. You are on a break, right? So I drew the arc. Now. Did you see? I drew the arc. So now let's see. I have to draw the arc in such a way it touches both the, see, like this, nicely touching both the sides. Okay, then lock it, remove it. Okay, now what do you do here? Put it here. You have locked it, right? Again, draw the same arc. Okay, and after that, please guys, if you follow, it's easy. Otherwise, you have to go to that link, web link, and practice. Now, what do? Unlock it, measure this, see, wherever the arc is touching the line, right? Measure that, lock it, okay? Then move it, bring your compass here. Now what do? You have locked it, right? So you don't have to worry. So you're going to cut the arc. Now you know what you do? You have to take this. You have to take this. You have to put the compass back. Let me see, guys. You have to take the compass out and then connect these. What and what are you going to connect? I'm not able to connect this and this, the intersection. So what is this? You copied angle A, B, C into A dash, B dash, C dash. This angle is congruent to this angle. Any questions? Any questions? Okay, so these basic things only are there in constructions. They won't ask you for much more, but again, there is a little more. Okay, now coming back, see, construct congruent segments, congruent angles. Then they want a segment bisector, angle bisector. They want a segment bisector, angle bisector, right? Can I go ahead and show? If you want to draw, go to that math pad. If you're not able to draw, just stop me, share the screen, I'll help you. Make sense?
Yeah.
Yeah, and you can always watch the recording too. The class is being recorded. Okay. Now I'm going to draw what? Where am I? I'm sorry, guys. Okay. Segment bisector, angle bisector, I can show you. It's not a hard one. Okay. Let's go back. You're going to see, it's the same thing in here. When you look at it, right? Copy a line segment, copy an angle. See? Bisect segment, bisect angle. Perpendicular from point on a given line, perpendicular from point not on a given line. Exactly that is in here. Perpendicular lines, perpendicular bisector, line parallel to a given line through a point not on the line. Exactly the same thing. So this is what I told you the first time when I discussed constructions. At least this piece, if you know, it's more than enough. But as a person who wants to know geometry nicely, I would really want you to learn this. Make sense? Make sense? You know, there was a point when I had done all of this in classes, geometry classes. It's no longer required and it's out of scope. Nowhere it is asked, so we are not doing it. You see what I mean? So from your end, it is enough. If you know this set and one more, if you want to, you can add this, but this is not in your benchmark. You don't have to. Make sense? Do you all have this web link? Otherwise, stop me and ask, do you all have this web link? Others, yeah, you have it. Yeah, Harshita has it. You have it, Diya?
Yeah, I do.
Okay, good. Okay. So now I can draw a perpendicular bisector quick. Okay, now I'm going to clean up this. Let's draw how to clean up this. Oh yeah, it's gone. So now I'm going to draw, let's say this is my line. Okay, I want to bisect this line. Okay, bisecting means what? Cutting the line into half, right? So this is A, this is B. You know what I do? I put my compass. I put my compass here. Let it be big. Unlock it. Make it bigger. Why I am making it bigger? For me to draw an arc up above, The thing is, guys, you're going to bisect the line, right? So basically, if you want to bisect the line, you have to draw arcs up and down. Okay, nobody is going to ask you to draw everything. They might ask you to find a mistake or fill in a blank, that's all. Okay, now with more than half, see, don't take it like this won't work. Your arcs won't meet up at all. See, if you have it like this, right, if you draw the arc like this, right, yeah, and then you have to say have the same arc here. When you want to do that, would you be able to see the two arcs won't meet at all? So that's not what you want to do. You got it? Am I making sense? So I don't want that. Instead, you see what I'm doing. If I want, oh, I'm sorry. If I want to bisect this line, let's say, oh my God, I want to bisect this line, let's say. Okay, I call it as A and B. I call it as AB. I want to bisect this line means what will I do? I will take this, move. First of all, I'll have to use my compass, bring it in here with more than half. Then only it will make the arcs connect. Then only it will intersect the arcs. So take this as radius, lock it. Take this as the measurement for the compass, and then lock it. Now go ahead and draw the arc. Okay, up and down, I would say, so that we complete two in one shot. So see here and then here as well, bring it down. Compass will not come down the first time you use this text pad and all. Okay, it will take time. Okay, you will have to get used to it. Okay, so now with that as center, don't change it. You have locked it, right? So nothing will happen. Okay, so now you have to draw the arc, right? It's not marking. See, it is making a mess for me. Hold on. So what I do now, I'll draw the arc. Makes sense? Then put it in here. Then come back. See, now connect these. And then take it up. Then again, cut the arc. From both the ends, you're cutting the arc. That's all. Okay, now what do? You connect you connect the intersection points. So what do you think? This not only bisected the line, but it also created a perpendicular bisector. Any questions? Actually, it created a perpendicular bisector. Make sense, guys? It created a perpendicular bisector. Any questions there? Any questions? Okay. Here, this is for a perpendicular bisector, but I said I'll bisect a line, right? So what is going to be the difference? Let's find out. There's going to be some difference. Now, I want to bisect a line means, let's say, I will erase this part. Hold on. I want to bisect a line, I said, right? So I have this. Okay, this line I'm going to bisect. You know what I do? I take the compass, place it here. Bisect of a line is pretty simple than this. Okay, I don't want this long. I unlock it. This is enough. Okay, this is enough. Lock it. See here. Okay, and then and then here, bring it in here, bring it a little bit here, yep, and then use the black color thing to draw. Oh, 1 minute, guys. 1 minute. This is bisector of a line, right? I think I made a mistake. You drew. Okay, let me restart it, please. 1 second, guys. I'm having a tough time with my. Okay. That I didn't want to take it out. This is for a purpose. You need to understand the difference between the two. That's why I took that. So this is a perpendicular bisector. Let me put it. This is a perpendicular bisector. Okay, why? This divides it and then bisects it. Makes sense? Now we are going to draw this one, a line. Okay, we are going to draw a line, and I'm going to bisect this. Okay, I am not happy with the line. Okay, how about this? I'm going to bisect this line, let's say. Okay, I'm going to bisect this line, so I'll take it. I don't need the compass to be this big for this one. Okay, so you see here, I keep it here, then I take it up, I keep it for more than half, lock it please. Okay, and then draw the arc up. Just like you did for perpendicular bisector, half of the work you need to do. Okay, see what I'm doing? Same, don't change the measurements. Don't change the compass measurements, don't unlock it. Okay, you will make a mistake. So now intersect the arc. Oh my god, I'm having a tough time. If it is physical, it's easy though. Okay, so here I'll intersect the arc like this. See, I intersected the arc. Now go up, take the compass up, move the compass up, keep it there. Then you know what you do? You can reduce this. Okay, you can reduce the size. So with this measurement, right, lock it and then draw an arc such that, see here, hold on guys. So how do we bisect it? Hold on. I honestly forgot this segment bisector. 1 second guys, I forgot the steps. Hold on. Perpendicular bisector I showed you, but I'm just finding the bisect a line segment. Oh yeah, bisecting a line segment is pretty easy. It's very similar to there, but it's pretty easy. Okay. Yeah, see, it's half of this actually. Okay. Okay, bisector is very easy. Yeah, the same thing here. Whatever we did here, we have to do, but I'll redo it, guys. Okay, so here I have this line. I'm going to bisect this line, right? So move the compass here with more than half, unlock it, more than half the distance, lock it, draw the arc. Draw the arc like this. Okay, similarly draw the arc here. You see? So once you draw a line that's connecting both, right, that's it. You connect a line joining both. Move the compass aside and then draw a line joining both. That's your bisector. Makes sense, guys? That's your bisector. Any questions? Any questions? Okay, now what else is asked? I need to check. What else was there? Angle bisector, perpendicular bisector of a line segment, line parallel to a given line through a point not on the line. Okay. That is an easy one again. On a given line is very easy. That's why they have given not on the given line. This one is easy. So you see here, for this one, okay, for this one, right, what you do, I'll tell you. Let me clear all of this. Do you understand? Okay. See, for a perpendicular bisector, they should see the arc on both up and down. For a line bisection, it's enough if you draw it like this. Okay. And then connect them. Now, let's say what was missing for us? Not on a given line. Correct. So, for that, let me go ahead. Not on I have to draw a parallel line. Oh So I have to draw on a parallel line through a given point, not on, okay, so this is the point. Let me quickly check on that as well. So this is the point, right? So they have given a point P. The intention is, let's call it A, B. So they are asking, what is the ask here? Draw a line through P parallel to AB. That's the ask here. Okay, so just a minute, give me, I'm going to pause the share. Let me see, or we can see together. This is not what we want, guys. Oh, this is a perpendicular. Okay, so they want a parallel line, so that is not a hard one. Okay, so here, you know what you do? Let me show. This is copying an angle. 1 minute, guys. Okay. So what do you do? I'll tell you here. Sorry, ma. Sorry. Here. You know what you do? I have to draw a line through P that's parallel to AB, right? It's pretty similar to copying a line segment. Okay, now let's see what to do. It's similar to copying a line segment. Let's see what to do. Yeah, so I have to draw a line through it parallel to this line segment. Makes sense. Okay, so let's see this one. Now what do I do? Okay, I take some point here. I take some point on AB. Let's draw it out and see. Okay, so what I do, you know, okay, let's say from here I am going to go back. Let's do it and see. Okay, I honestly forgot how to do. Okay, let's see. Here I would go ahead and draw with more than half the radius, guys. Always with more than half the radius, half the measurement. Okay, so here let me lock it. Now let me go ahead and draw this arc. Okay, now okay, now what do I do? I'll place it in here. Oh my god, I can't draw that. Okay, let's see. 1 minute, guys. I'll place another point P here so that I'm able to do. Okay, now let me go ahead and do the same thing for this line. Let's see together. Okay, I don't really remember this one. I will put it in here and then again draw some things. Will that come? I don't know. Okay, but that's not making sense, right? Yeah, 1 second, guys. See, through a point on the line means it will come, but 1 second, guys. 1 second, give me a minute. I need to check the steps. Oh, okay, makes sense. I missed a step. Okay, let me clear out all this. So the okay, I didn't want to do that. Hold on. Okay, so let's say we have to draw a line. This is our line segment AB. What we want is draw a line through P. Let me take this out. I don't want this. Okay, this is my point P. Why I am keeping the point P down is top as well I can keep. I cannot draw arcs properly with the compass online. That's why I'm keeping the point down. Okay, now what I need to do is first draw a transversal. Okay, to draw the parallel line, right, I would go ahead and draw a transversal through point P. Does that make sense, guys? When I draw the transversal, everything becomes easy. I forgot the transversal and that was a problem. Okay, now here, adjust the length to a little less. Okay, now let's see. Simply a straight line, okay, which passes through P and intersects. Using the construction, copy the, you just need to copy the angle. Okay. Yeah, then it becomes very easy. But see, we need to just copy the angle. Let's see. So now I'll first draw this. First draw this means I'll copy the angle. Literally, I'll copy the angle. That's all. The construction ends there, looks like. See. Now I'll put it in here. Put it in here. For copying the angle, first I'll draw this, right? And then what do I do? Just like what I did for copying the angle, I would do. I will go here. I will go here. Measure this. It's already unlocked. Measure this angle. Measure this angle. Lock it. Bring it in here. Copy the angle. That's all. Now take out the compass. So this is the line through P. See, now you can say you have drawn A dash B dash parallel to A dash B dash parallel to AB. First, what do? You have the line AB, you have the line point P up, let's say. Now what do? You draw a transversal. Now take a compass, copy the angle, keep it in here. Put it like this. Similarly, keep it in here, put it in like this. After that, measure this distance using your compass. Then what do? Go here, cut an arc. So when you connect those two, that line will be parallel to this. Any questions? Any questions?
Okay, what were the last two steps again?
Sure, I will redo it. What big deal, right? So let's do. 1 second, I'm getting confused with MathPad controls and Zoom controls. Okay. So I have this in here. I have this in here. What was my requirement? To draw a line parallel, right? Okay. Okay. Let this be my angle. Let this be my line. Okay. Through a point not on the line. See, this point should not be on this line. That is your requirement. Okay. Your requirement is draw A dash B dash parallel to AB passing through P. That was the requirement. That's what is in your benchmark. Okay, so how do you do it? You are just going to drawing the transversal is the secret step that I missed. Okay, so choose and draw a transversal. Okay, you can draw the transversal even up. Okay, draw this transversal. Then it becomes easy. Okay. Wherever it is, it's okay. Now what you do, you copy the angle, that's all. How did you copy the angle? Take your compass, move it here, push it a little bit, okay. Lock it, then copy the angle. For copying the angle, what did you do? You drew this line first, then keep it in here, draw the same line. Okay, see, draw the same line, okay. After that, what do? You have to measure this. Unlock it, measure this distance. See, that is what is quite important. Okay, lock it. Now you have to copy that in here, right? You see, this has to come this side. So, put it in here. I'm not able to draw, guys, here because it went up. Okay, now I'm able to. So you know what you'll do? You'll just cut the arc. That's all. Now, what you do? You're going to connect these two. See, that line, what line? A dash, B dash. See, this line A dash, B dash passes through P. So A dash, B dash is now parallel to AB, passing through P. Make sense? Johan, did you get it?
Yeah.
Okay. So, even if you forget, right? One is depend on the recording. Other one is I showed you the link, right? MathBits notebook. Everything is in there. But you know what? Going through that, studying it is going to take a lot of time. Okay, any questions? Okay, now spherical Euclidean geometry, the difference is pretty easy. I just want to cover that and then go to probability so that we can cover probability in the upcoming class once more as well. I'll get you to cover probability, but wait, I need, give me a few minutes, guys, okay? Probability. Okay. Okay. Euclidean geometry, spherical geometry, we can do it even the last class before it's just, see, very subtle differences, okay? There is one another, what we study is Euclidean geometry. Why it is called Euclidean geometry? Because the geometry, the postulates were all discovered, or what do I say? The postulates were all framed initially. Euclid has a lot of involvement in developing our geometry, so what we study is Euclidean geometry, okay? But in spherical geometry, right, meaning everything is considered as spheres, okay? Here you have a plane, right? There is no plane there. Instead of a plane, there are circles, okay? So a line, here it's a line, right? There they are not lines. They are called great circles, meaning circles around the line. A line is equal to a great circle. Makes sense? And then the end points, right? We call it end points of a line. This is a line segment, right? Here, in Euclidean geometry, it's a sphere, I said, right? So the line is equivalent to a great circle, correct? The line is equivalent to a great circle, a circle around the sphere. Okay. Now, so if you draw a triangle, right? In a plane in Euclidean geometry, the sum of the angles in a triangle is 180. Here, automatically the sum of the angles in an Euclidean geometry triangle is greater than, let's say, A, B, C. In Euclidean geometry, it's A plus B plus C is more than 90 degrees, 180 degrees. I'll give you notes on this. Okay. These are subtle difference, there's a lot of difference between spherical geometry and Euclidean geometry. Spherical geometry is really hard. Okay. So, the endpoints of a line in Euclidean geometry is the endpoints of great circles in the sphere are called antipodal points. It's just factual thing that you need to know. Okay, antipodal points. Okay, anything else that you need to know? Yes, there is a few more. Hold on, let me get that for you. You're going to patiently wait. I have it. Okay. I told you, right? I was drawing and showing you. Let me put it nice figures for you. Yeah, this is so much better. I'll share the same notes with you as well. See, I told you about the great circles, right? The center of the sphere. You see, that's the center of the sphere. Now, a line in Euclidean geometry, plane and a line you see in Euclidean geometry, right? That is equivalent to a circle, and that's equivalent to a sphere in great circles. Do you see this? Do you see this? Do you see this? You see? That is the circle. So here, sum of the angles will be equal to 180. Sum of the angles will be greater than 180. Any questions on that? So those are the important ones you need to know. And then antipodal points I told you. What else is there? Okay. Nice. This one I really want you to know. Okay. You have heard of the parallel postulates in Euclidean geometry, correct? So if there is a line and a point not on the line, there is exactly only one. See, in Euclidean geometry, if there is a line and a point not on the line, right, there is exactly one line that goes through the point and is parallel to the line. If there is a line and a point not on the line, then there is only one line that can go through the point and parallel to our given line. There can be only one line CD that can pass through our point and can be parallel to the given line. Okay, but in case of spherical geometry, do you think that will hold good? Do you think that will hold good? What do you think? Line is equivalent to a great circle, right? What will happen in a sphere? Will you have parallel lines, or what do you have? What will you have? What will you do?
There'd be like multiple.
Do you think there'll be multiple lines? Okay, let's find out. Where is it? Okay. You know the red line, let's say the line, the great circle M. Okay. Here you have line L. If you think about A, there can be only one point parallel to the given line. How many? Okay, now you have M, the great circle. Okay, I have a point on the sphere. What do you think? Through that point, can there be a great circle? Let me show you with a figure. How about this? What do you think here? There is a line L. I want to draw, there is a point A. A is not on the great circle. Okay. Do you think I can draw another great circle through A parallel to L? Guys, I need your inputs, please. Think, it's okay to go wrong, right? Can you draw a great circle through A parallel to L?
No.
Yes. No, you can't. So there can be no line parallel to L. Got it? Okay. Other than that, you don't need to know anything else. Okay. So that's it. That's enough for your benchmark. But I will share much more than what you need. Okay. Again, I'm going to share much more than what you need, but what you just need to know is that the sum of the angles is more than 180. You should know what are antipodal points. Then you should know the parallel line postulates in Euclidean geometry does not hold good in spherical geometry because there can be no line parallel to another line L. What else did we discuss? And great circles are equivalent to lines in a plane. Okay, I have shared one link with you which is for spherical versus Euclidean geometry. Make sense? It's just few pages, 1 or 2 pages. It's more of factual thing. There's nothing, meaning you don't need to know the area of a spherical triangle, all that you don't need to know. But the notes give you much more than what is really required. Okay, can we go to probability now, which is a bigger unit? Can we go to probability?
Yeah.
Okay. So now coming to probability, right? Okay, let's see how many parts are there first. What and all you need to study, I'll let you know. Now I'll cover some of them, but you have to. Okay, so for how many parts are there? 1 minute. Okay, it's pretty short. but I'll tell you what to study and what is important and stuff. So we'll see. Okay. Okay. Time is 21. We have 40 minutes, which is good. Hey, I said I'll run the class for at least 1.5 hours. Did your moms tell you? Did your moms tell you? Yes, no. They told you, okay, good. I'm planning to run it for 1.5 hours at least, okay? So let's see. So that way I am convinced that you know everything, guys. That's more important for me, okay? Yeah, now I don't want this. 1 second, guys. Okay, now we'll start with probability, you know, from grade 7, right? The basic definition of probability, you know, right? Measure of a chance that an event would happen. Makes sense? You know how to do that? See, throw a die. We'll be quick in revision of this. We will revise this quickly, okay? In a fair-sided die that has 6 faces, right? What is the chance I'll get a prime number? What is the chance I'll get a prime number? So my this is read as probability of an event A. What is that event A? Event A is throwing a prime number. So what is the probability? Tell me, guys.
2/3.
So what are the prime numbers? 2,
1, 2,
5.
3, 5.
No, 1 is neither prime nor composite.
Oh.
See, that sort of a knowledge is what is important when it comes to probability. Okay, 2, 3, 5. So 3 out of 6 is 1 out of 2. Make sense, guys? Okay. Now, see, in probability, if you have studied with me for grade 7, then you... grade 7 means grade 7 class. If you had been there, then we would have definitely done dependent independent probability, not the AOPS class. If you have been with me for grade 7 class level, grade 7, then dependent independent probability was a part of it, okay? But here in geometry we start learning with geometric probability. Geometric probability is pretty easy provided you really understand what needs to be done. Let me erase this off, guys. I don't feel the need for this in here. Okay. Okay. Geometric probability is pretty easy. I'll tell you what is geometric probability, okay? So, let's say I have a line. Let me give you this. Let me give you the concept first and then we'll see. Okay, here we go. Okay, now suppose there is a line segment RS. This is your line segment RS. See, this is your line segment RS. Now I choose a point M at random. I can choose this, I can choose this, I can choose this, I can choose this, I can choose anywhere, okay? I'm choosing a point M. What is the probability if I choose that point, right? What is the probability that it will fall within KL? What is the probability? You tell me. The length KL divided by RS. Same thing, you see, this is the favorable length. This is the total length. Does that make sense? So, this is pretty easy, right? Now, let's see whether you're able to do this. Okay. You're going to tell me, okay? For this line, I am going to delete all of this. If given this line, right, I am choosing a point. What is the probability that it will lie on AB, the green portion of it? Quick, it's not hard. What is the probability that it will lie on?
We type it in the chat.
How much?
We type it in the chat or just like shout it out?
Just shout out. It's
half.
half. How many of you didn't get it? Please raise if you didn't get it.
Miss Priya,
Yes.
did you just add 6 and 2 on the right side and just say like half because it's 8 and 8?
No. the length of AB by the length of the total, right?
Oh, okay.
16. You got it?
Yeah.
Okay. I'm glad you asked. How about this? You're going to try it out yourself. Now you're going to chat this to me. You chat the answer to me. I don't think you've done these units. Let's see. In a 5-minute traffic cycle, a traffic light is green for 2 minutes 27 seconds, yellow for 6 seconds, and red for 2 minutes 20. At least explain how will you do. You don't need to do it, but I want to know how you'll do it. Harshita, you want to say, ma? What is the probability? See, favorable by total. That's all. What is the favorable thing? Green.
So first you have to like convert it all to seconds.
Very nice. First, you will have to convert all to seconds. Many of you forget that. Good. Don't do minutes and seconds. Yes. Convert everything to seconds and then.
And then you put the green time over the total cycle.
That's it. Yes. Can I move on? This is a challenging question. Let's see. This is a challenging question, but please answer this in chat. 24-gallon tank is full. What is the probability that the engine is turned on? The needle on the gas gauge is pointing between 1/4 and 1/2. This is what is real geometric probability. Okay. Have you seen the car? The fuel indicator? This is the fuel indicator, right? Full empty. What do you do? This is 1/4, 1/2, 3/4. What do you do? It's the full is 24 tank. If it is full, it's 24. So what is our favorable event? Tell me, guys.
It's 40 between 1/2 and 1/4.
Yeah. So what do you think about it? What is the probability? Is it one? Harshita is correct.
Oh, wait, I got it.
What do you think? We want only this piece. This is my favorable unit. So what is the probability? You tell me, ma. Favorable by the total. What do you say? You go with areas, right?
Is it 1/4?
Is it 1/4? Yes, it's 1/4. Avyukt, yes, we can go over. Okay, now full geometric probability really depends on that. Let's see. How about this? You want an easier problem at first, right? Yeah, you would definitely want an easier problem. Okay, let's see this one. Okay, let's see this one. You can just describe this. This is an easy problem. See here. What is the probability that the spinner will land on red? What is the probability that the spinner will land on red? Who can tell me?
40%.
It's
Would it be
40.
1/9?
That's right. So it's 40 degrees, right? This is 40 degrees. The total is what?
Oh, I thought that said 40%.
Percent is this sign, right, Amma? You got it? Okay. So depending on what is given, you have to choose. This one is difficult. Let me see. How about this? This one is a little difficult. Let me see. Find the area of the shaded region. Then find the probability that a point chosen at random is in the shaded region. Okay, now let me show you what is the shaded region. That is going to be hard, right? See, this is where I'll wait and watch, okay, how you apply. Okay, here. You want to know the shaded region, right? Let me show you the shaded region. So this is going to be 1, 2, 3, 4. It's a regular hexagon, okay? Now I want to know this. Okay, now the question is, Yeah, I have written the question there. Find the area of the shaded region. Then find the probability that a point chosen at random is in the shaded region. How do you find the area of the shaded region?
You subtract the total area of the circle by the area of the hexagon.
Correct. Total area of the circle. Okay, total area of the circle, how will you find out? Okay, let's say this is 11. Let's say the diameter is 11. Total area of the circle you will find with the diameter, correct? So this will be 5.5. That is easy for you. You'll find the total area of the circle. Then what do you do?
You use trig ratios.
Yes, you'll use trig ratios. But do you need to use trig ratios here? It's a hexagon. Pentagon, you need to use trig ratios.
Special right triangles.
Oh, okay.
Yeah, special right triangles, 30, 60, 90. You got it? Once you have the 30, 60, 90, right? See, hexagon, that's why this I have repeated in class. 30, 60, 90 triangles, you can always cut them into two and it's so easy to do. This is a 30, 90, 60. Okay? You know this radius. One side you know, right? This is a 5.5, right? Based on this knowledge, you can really figure out the rest. Once you figure that out, right, you will get the area of the hexagon very well because this area you can clearly get it quickly. This is repeated 12 times. So that is the area of this hexagon. You get the hexagonal area. Then what do you do? From the area of the circle, you will subtract the area of the hexagon. Right? Whatever is remaining, right? This one, right, is this, 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 correct? But you need only, so that is 6 parts. So what you will do, of that only 2 parts you need. So 2 by 6 of that is the answer. Got it, guys? Harshit, are you following? Okay. Diya, did you follow that, ma?
Yeah, I did.
Okay. Okay. So geometric probability will all be similar to this. I'll share the worksheets too for this one. What else I wanted to? Oh, okay. What is sample space, ma? This we have discussed again and again in the 7th grade class. I don't know if you have done the 7th grade class. What is the sample space?
It's like all the possible outcomes.
Yep, all possible outcomes. That's it. Okay. They'll ask you all possible outcomes a lot. Okay, and one more thing. This type of problem you have studied. Okay. Let's see. How about this? Think about it, okay? I go to an ice cream shop. This is basic counting principle. Okay, I go to an ice cream shop. They have 2 base flavors. Okay, 3 toppings. Okay, and you can use chocolate syrup or you can use strawberry syrup or you can use dark chocolate syrup. Okay, you plan to use all the 3, one in all the 3. You are allowed to pick one in all the 3. Okay, if you decide that you will pick one in all the 3, how many possibilities are there? How many possible combinations of different ice creams you can have? Let's say,
18.
how do you know?
I just multiplied 2
Yep,
times 3
yep.
times 2.
3 times 3 times 2. Makes sense? Why? Because flavor 1, flavor 2. Draw the tree diagram, right? 2 flavors that each can be combined with topping 1, topping 2, topping 3, topping 1, topping 2, topping 3. And then what do? Then you can use syrup 1, syrup 2, syrup 3, syrup 1, syrup 2, syrup 3, syrup 1, syrup 2, syrup 3, syrup 1, syrup 2, syrup 3. Like that you can have 3 in each. You got it? That's it. Okay. Now that is basic fundamental counting principle. Okay. Now sample space is okay. Then, okay, I think I need to make a note of all these links myself first, because, one second guys, how many are there? Hold on. Yeah, I feel like I need to copy. This is for, I will put this in the classroom as homework for this class, okay? Probability part 1. Okay, then with that, probability part 1, but I need to do more right with you guys. Okay, now when do you use okay, suppose let's say, do you all know factorials? How many of you know factorials? Do you know factorials?
Yeah, I do.
You do? Okay.
Yeah, I don't.
Okay. So basically, what is 3 factorial? Means, you know what? I have heard, I don't know whether it's a myth or was real. Okay. Why did they come up with the exclamation mark? Because whatever result came up was very huge. That's why they came up with the exclamation mark. 2 factorial is 2 times 1. 2. 4 factorial is 4 times 3 times 2 times 1. 5 factorial is 5 times 4 times 3 times 2 times 1. Did you get what is the meaning of factorial?
Yeah.
Product of all numbers from 1 to that number. Now what is 10 factorial by 2 factorial? 10 factorial by 9 factorial. What is 10 factorial by 9 factorial? Let's see guys. Think deeply. You will automatically tell the answer. I don't need to teach.
Would it just be 10?
Yeah. What happens? How it becomes a 10?
Because
Sure. 9 factorial said cancelled out.
Exactly. Everything will get cancelled, right? So it's 10. Now, what is 16 factorial by 14 factorial?
would it be 16 times 15?
Yeah, you got it. Rest of it will get cancelled. Times 14 factorial by 14 factorial. This and this will get cancelled. Make sense, guys? Ashrita, are you following Ashrita?
Yeah, sorry.
Yeah, but I doubt Ashrita really. Okay. Now, there are 2 things, guys, okay? When you want to find the number of arrangements something can be positioned. Suppose, let's say, you, your mom, dad, brother, you all want to pose for a photo. In how many ways? Dad, mom, brother, sister. Brother, sister, let's have. Okay, I'm considering you as a sister. In how many ways can all of you be positioned? There are multiple ways. D can be the first. And then I can have M, B, S. See, I can draw a tree diagram. It's so hard, but every time I can't keep drawing a tree diagram. First, dad is first, let's say. Then, the second option can be mother, sister, brother. If mother is the second option, third option can be sister, brother. Here, the fourth option is a brother. Here, the fourth option is a sister. Here, dad and sister are standing. Then it can be a mother and a brother. After mother, it has to be a brother. After brother, it has to be a mother. Like that, you have 2 options here. What are the 2 options? Sister and mother. Then 1 option, right? Like that, you have 4 sets. Mom can be first. Sister can be first. Brother can be first. So each of these 4 options is coming up with how many? 6 values. So how many ways can you be positioned?
36? No, wait, 24?
How many ways of arranging you all are there for a photo?
Is it 16?
24.
Why 6? 24, right? 6, 6, 6, 6, right? See, dad was the first, and then mom can be the first, then sister can be the first, and brother can be the first. With each arrangement, you can have 6 possibilities, right? Am I making sense, Dia?
Yeah, you are.
It's absolutely fine. If it doesn't make sense, you can let me know.
No, I get it. I think I just made like a mistake in the calculations.
No worries at all. Okay, as long as you understand, I'm good. One thing what you need to understand is when you want to pose for a photo, right? Order is important. You see, let's say 3 people ABC. If they want to pose for a photo, order is important. ABC is different from ACB. You got it? The order in which they come is important. B can be first and then it can be AB or BA. I'm sorry, AC. AC, then B can be first and then followed by CA. And then C can be first followed by AB, or C can be first followed by BA. So here, do you see, for posing a photo, order is very important. Then what do? Then you go with permutation. There is a concept called permutation in probability where the order becomes very important. Make sense? But what is permutation? How to get this quickly? There are 3 people, okay? How many different people can go here for the first one? 3, correct? Once you position one of them there, right? How many different possibilities are there for this position? Tell me. There are 3 people, so 3 possibilities. For this position, how many possibilities?
2.
2. For this position?
1.
1. So you multiply all the 3. That is permutation. You got it? Make sense? Suppose if there are n people, I want to choose r people. If there are n people and I want to choose r of them. You see, if there are n people and I want to choose r of them, right? Literally, how do you do, you know? N factorial by n minus r factorial. That is your formula. Suppose if there are 5 people, okay? In how many ways can let's say I let them run a race, okay? They are running a race. I need to award first and second prizes, right? In how many ways how many possible combinations of pairs I can get for the first 2 places? Do you think the order is important? For the first 2 places, I am choosing people. Is the order important or not? Yes, because let's say there are 5 people, A, B, C, D, E. I can choose AB or I can choose BA for the first and the second place. It is different. AB is not the same as BA. You see it? So, the order is important here. As a result, I will permute. How will I permute? There are 5 people. Permute, how many people? 2 people. So, I'll say 5 factorial by 3 factorial. What is the answer? What is the answer?
Is it 20?
Yeah, 5 factorial by 2 factorial. Harshita, did you get it, ma?
Yeah.
So, permutation works based on order. Okay. Combinations doesn't work based on order. Other thing is combination. That does not work on order. Okay. Order is not important. Let's say there are same 5 people. Let's say there are 3 people. Let's say there are 3 people ABC. Okay. I have to pick 2 of them. How can I pick 2 of them? I can choose basically AB, or I can choose AC, I can choose BC, or I can choose AB, I can choose AC, I can choose BC. Suppose if order is important, then I can choose AB, I can choose BA, I can choose BC, BA, I can choose AC, I can choose CA, I can choose BC, I can choose CB. Do you see when order is important? I have 3 people, you pick 2. So how do I write permutation? 3 permute 2. So 3 factorial by 3 minus 2 factorial. What is it? 6 by 1 factorial. 0 factorial is 1, guys. 0 factorial is 1. Remember that. 6 factorial by, 6 by 1 factorial, which is 6. There are 6 different ways when I don't consider when I consider the order. When I don't want the order, it becomes combinations. What is that? I can write that as n combine r. N choose r basically. If you write the formula for n choose r, it's the same thing, n factorial by n minus r factorial. But the duplicates, these two are duplicates, these two are duplicates, these two are duplicates, that need to be filtered out, right? So 3 choose 2 means you are filtering out of 2 you choose 1, out of 2 you choose 1, out of 2 you choose 1. So you divide the entire thing by r factorial. Make sense? That is how you filter out the duplicates. So how many ways I can choose? 3 choose 2 is different. 3 factorial by 2 factorial times 1 factorial is 3. Make sense? Does that make sense? Okay.
So there are more permutations and combinations.
What do you mean by that?
Like whatever you said, like right now, for example, CB and BC, that's good. One
You
is
will
gonna
get,
be like cancelled out.
correct. You will get more permutations than combinations. Answers for permutations will be much more than combinations.
Okay.
Make sense? Make sense?
Yeah.
Okay. Now let me ask you this. What is this permutation or combination? I just want to know in how many different combinations are possible means your answer will be a big number. Remember guys, this is very important. They're asking for how many different combinations. What do you do? What do you do for this one? 15 soccer trophies are there, but only has room to display 9 of them. What do you think? Is it combinations or permutations?
I think it's combinations because I don't think the order really matters.
Yeah, it doesn't matter. The trophy 1 I can put it first or trophy 9 I can put it first. Doesn't matter. I have to display. That's all. So it is combination. So you will go ahead with 15 choose 9. Got it? It is 15 factorial by 15 minus 9 factorial and 9 factorial. Make sense?
Yeah.
You'll have to sit and compute these, okay? Or I don't know whether they allow you to use a calculator. That you need to check.
Yeah, so if it's a combination, it's 15 exclamation mark over what?
Ma 15 factorial ma. N factorial by r factorial n minus r factorial.
Okay.
Make sense? Okay. Now,
Miss Priya,
yeah.
what are the words they're gonna be using for permutation and the words they're gonna be using for combination? That like keywords.
Don't go by that. Go with the context and see whether the order is important. Okay, that's crazy to go with that. Okay, this was
Okay.
one question I remember 2-3 years back. There was one girl who was very good with probability but came back asking me how to do this. I clearly remember. So, do you think you can do this? 5 students are asked randomly select and name a polygon from the group below. What is the probability that the first 2 students choose a triangle and a quadrilateral in that order? Oh, wait, guys. Before this, I want to give you something else. Hold on. I don't want you to do that, okay? Okay, see, probability is different from number of ways. If they ask for the number of ways something can be done, right? If they ask for the number of ways something can be done, you're going to choose permutations or combinations, right? Now, here you see they're asking for probability. Then it is numerator by denominator. It will be a fraction. So you have 1, 2, 3, 4, 5, 6 textbooks. You have to take geometry book will be first from the left and chemistry book will be second from the left. Oh my goodness. Spanish, English, chemistry, geometry, history, psychology. But they want geometry book to be the first. G's position is already placed. Okay, chemistry book will be the second to left. So you have these spaces left out. How many possibilities are there? How many ways are there to place book in here?
4.
4, because there are only 4 of free options. So 4. How many ways, how many books can be placed here after placing that?
3.
3, 2, 1. Correct? So how many ways are there now just for these 4 books? Because 2 are constant, you cannot change them. 12, 12 times 2, 24. So this is the favorable combination. You see, this is they're asking for probability. So this is what is the favorable numbers. But what is the total? In how many ways 6 books can be arranged? In how many ways 6 books can be arranged?
6 factorial.
Factorial.
6 factorial. Huh?
6 factorial.
Yeah, this is 4 factorial, right? So basically it's 4 factorial by 6 factorial, which is 1 by 30. Got it? If they ask for probability, it is favorable by the total. Okay, if they ask for number of ways, then it is permutation or combination. Probability, you can end up choosing, even in probability, you can end up choosing combination by combination or permutation by permutation. Got it? Now, let me come back to that question. I don't remember how we solved it then, but I remember solving it for her. Let's see. How about this? 5 students are asked to randomly select and name a polygon from the group below. What is the probability that the first 2 students choose triangle and quadrilateral in that order? Wow. What do you think? I need to check this. Okay, 5 students are asked to randomly select and name a polygon from the group below. Okay, what is the probability that the first 2 students choose? So what are the favorable ways in which the first student chooses a triangle? What are the number of ways in which the first student chooses a triangle? Think in that regard.
It's just 1.
Yeah, is it 1? Okay. Yeah, go ahead. Yeah, it is 1. Good job. And then? First 2 students correct. So what is the probability that the second student chooses a quadrilateral? What do you think about it?
Are you explaining something?
Oh, yes. Yes, I was. So think about it this way. First two students, right? Now I'm going to talk about number of, see, basically probability they've asked. So number of favorable ways by number of total ways. Okay, so that's it. That's what we need to do. But the number of favorable ways is, what are the favorable ways? First student chooses triangle. Okay, and then again they're asking the second student as well, they have something, so you need that also to happen. Second student chooses quadrilateral, that you need to multiply, right? Divided by, for the first two students only you are thinking about, right? So first student choosing any of the five, first student, second student choosing what is left, that you need to multiply, that is the total, right? So what do you think about it? He says this is 1. Okay, what is this? Second student choosing a quadrilateral, this is gone, so second student has to choose a quadrilateral. How many number of ways is it possible? Try, guys.
Would it be 4 factorial?
That is the total, right? It's not a hard question, guys, meaning it's just very practical. You are going to choose, see what are the favorable number of ways. First student should choose a triangle, second student should choose a quadrilateral. First student choosing a triangle is only 1, right? That's the only favorable way. Second student chooses a quadrilateral, how many favorable ways are there? 1. There is only 1. Wait. Second student chooses a four-sided figure. Yes, there's only 1. You got it? Now, first student, basically, he has a total of 5, right? And he can choose 1. Do you get it? What does 5 choose 1? Oh, yeah. What is 5 choose 1?
Just 5?
Yep, 5. The second student choosing. See, the thing is, a second student can choose anything, right? Four objects are there. He has to choose 1. Make sense? So what is it? 1 times 1 divided by 5 times 4. 1 by 20. Does that do good? Okay, let's do a little more on this, guys. Doesn't matter if we run out of time. Let's see. Oh my god. Okay, let's see this one. Okay, how about this? You're going to try this one, please. Okay, what is the answer for this one? You're going to try this one, okay? You can send the answer. Linda, Troy, Bailey, Spencer are being positioned for a photograph. What is the probability that Troy is chosen to stand on the far left, Spencer on the far right? Two positions are already placed. There is no way you can change them. But please see there, they're asking for probability or number of ways. Probability means it has to be a fraction. What do you all think? I'll wait for your answers. Oh wow, Harshita, good job on the previous problem. Try, guys. That's right, Johan. Harshita, that's right. I need other answers. Not a hard one, right? Ashita, that's right. Good job. Did you get it? Dia, did you get it, ma? Avyut, I
I'm
want.
almost done solving it.
It's okay. Just try, guys. Yeah. Okay, I need to go over two more concepts important in probability. Rest of it, I'll give the you study, you read through the PDF. I can tell, but at least two more concepts I have. I want to cover that and let you go, at least at the conceptual level. Okay, then I'll share the homework with you. You can go through the notes. Okay, you're confused, Avyuk? No problem. So, Linda, Troy, Bailey, Spencer. Linda, Troy, Bailey, Spencer. There are 4 places, right? In how many ways can they be rearranged? This place can be taken up by 4 people. This place can be taken up by 3 because I already positioned 1 here. Now, this place can be taken up by
2,
2. This place can be taken up by
1.
1. So, basically, it's 4 factorial. That's the total possibilities, right? But they are saying far left is Troy, far right is Spencer, right?
Mm-hmm.
How many people can take up the space?
1 person.
2, right? There are 2 people. There are 2 positions, right? And 2 people are there. 2 people can take this.
Mm-hmm.
Either see this and this are gone, but this can be taken up by L or B, and this can be taken up by L or B.
Mm.
You see what I mean? 2 people can go in there. I position one of them here. Then I have only 1. You got it?
Yeah.
That is 2. So 2 by 24 is 1 by 12.
Okay.
Okay.
Yeah, I see.
Now, the last 2 topics that I needed to touch upon is okay, independent dependent probability we have already done. Let me see. Okay. I really want you, I don't know whether you will be able to solve this one. We have done from a bag of 5 red marbles. If you have done class level grade 7 with me, I would have done with you. 5 red, 6 green marbles if you are there. Okay, a red marble is drawn. Okay, then it is not replaced. You see, then a green marble is drawn. What is the probability of RG? No replacement, meaning you're not replacing it. So if you're not, okay, suppose the same, first let's do this, guys. 5 red, 6 green. Okay, now you are taking a red, replace that red, then you take out green. What is the probability of which is dependent, which is not dependent? You put it back into the bag. Here, you put it back into the bag. The bag retains the same. See, the bag before you take this is the same as the bag you take before you take a green. So the bag's status is unchanged. So is this dependent? Is picking green dependent on red? Yes, no, what do you think? Which is dependent probability, which is independent probability here? Try, guys. Johan, you try.
Would the first one be dependent?
This is dependent because you take out the red. Okay, when you take out the red, it becomes 4 red and 6 green, and then you pick out the green because you're not replacing it. You see, so picking the green is really dependent on the red. So what I would do, first 5 reds, right, out of 11 balls. I multiply that with what is the probability to take green? 1 reduced, right? So the number of balls become 10. So 6 out of 10. Am I making sense? But here, what happens? So this is dependent probability. You need to be careful because you need to remember the numbers in the second. Here it's very easy to take out red, it's 5 out of 11. Then I replace it. So it's 6 out of 11. Makes sense, guys? Harshita, does it make sense?
I got it.
Okay. Now, the last one, okay. One is, the last concept is mutually exclusive and not mutually exclusive events. Okay. Mutually exclusive and, another 5 minutes. Mutually exclusive and not mutually exclusive. What is mutually exclusive? Two events that cannot happen at the same time and have no common outcomes. They are mutually exclusive. What does it mean? Let's consider the scenario. I just want you to understand what is mutually exclusive and what is not mutually exclusive. We'll finish with this. At Memorial School, sophomores, juniors, seniors can all run for student council president. Dominic wants either a junior or a senior candidate to win the election. Travis wants either a sophomore or female to win. But says if the winner is sophomore Katharina Smith, I am thrilled. He wants either a sophomore or a female. Okay. This is the scenario. Okay. Now, why would Travis be thrilled if Katharina wins the election? Why would Travis be thrilled? Why do you think Travis will be thrilled if Smith is going to win the election? Why do you think?
Because she's a female and a sophomore.
Exactly. She's a female and a sophomore. See. Okay. This can happen at the same time. So, okay. So now she is a female and a sophomore. Good. Now let me ask you one another. Can a person win the election that both Dominic and Travis want? Can a person?
No.
Why?
Would it be like a female junior or senior?
Exactly. So what you all
Oh.
can a person win the election that both Dominic and Travis want?
Yeah.
Yes. When? Why? If the person is a
No.
junior or senior and female, you got it?
Yeah, but like I thought you meant like all of it, and I was like, you can't get all of it at the same time.
Yeah, but you got it now? Okay, now let me ask you this. Would either Dominic or Travis be happy if a freshman Monroe won the election? Would either Dominic or Travis be happy if a freshman Monroe won the election? No. So we will now understand what is the relationship between mutually exclusive and not mutually exclusive. Mutually exclusive means two events that cannot happen at the same time. Okay, in this scenario, right, let's say Monroe, Monroe is a male, okay, male, and let's say he's a senior, okay. Mm, okay, let me give you another example for mutually exclusive events. I have to expand this if I want to show you. Okay, okay, how about this? Tell me this. Are these mutually exclusive or not? You're going to help me find out. This is easier than handling with this. Let's see. Handling this for mutually exclusive. Let's try this one. Which of these is mutually exclusive? You can ride a bus to school or you can ride in a car to school. Can you ride both to school? What do you think? Can you ride both to school?
Not on the same day or like the same time.
Yeah, so are they mutually exclusive?
Yeah.
Yeah, you can't do both, right? You can't do both, right?
Yeah.
Okay. Let's see. I'll give you one more. Okay. Now, when a die is rolled, what is the probability of getting a 2 or a 5? Now, is this getting a 2 or a 5, is it mutually exclusive? Or they are not mutually exclusive? What do you think? They can't happen at the same time means then it is mutually exclusive. So what do you think? Rolling a 2 or a 5?
They're mutually exclusive.
Yeah, it has to be a 2 or a 5, right? Okay, so now very clearly probability of mutually exclusive events is this. Probability of mutually exclusive events means this or that means you have to add them. You got it? Does that make sense?
Yeah.
Okay. Now, probability of not mutually exclusive events. I'll tell you one example. Okay. Let's say a die is rolled. Okay. A die is rolled, but I'm asking about the probability of probability of number greater than 2, probability of even. Are they mutually exclusive or no?
They're not.
No, they are not mutually exclusive. You see, that's the difference, guys. Okay, now the thing is, if they are mutually exclusive, it's very easy. Okay, this is just addition because they are never going to coincide. But here they are going to coincide. It can be a 3, 4, 5, 6 on this, right? And then it can be 2, 4, 6 on this. So, you know what you do? Probability of mutually exclusive events, right? So, A or B will be equal to probability of A plus probability of B minus probability of A and B. A and B is written like this. You get it? A intersection B. So, what is that? Probability of A here is 3 by 6. Probability of B here is 3 by 6. And what is the intersection, guys? What is the intersection? 2 by 6. Right? What is the answer now? What is the answer? Probability of A is greater than 2. So I see 4 by 6, right? You're also keeping quiet. Is this not 4 by 6? 3, 4, 5, 6. This is 2, 4, 6. And then you subtract 2, which is common. So this is 5 by 6. Make sense? So the basic concept between mutually exclusive and not mutually exclusive, did you understand? Okay. Yeah, but the main thing they might ask is something like this. I will stop here in another minute. You can play chess. Yeah, with whom?
With the computer.
Yeah, you go play. Yeah.
Only chess.
Okay, I'll end with this, guys. Okay. How about this? There's a table given, right? Right? What is the probability that a person on a student council committee is a junior or on the service committee? Person on the student council committee. So what are we asking? Probability of a junior and on service committee. A junior or on service committee. What do we do? Can a junior be on the service committee? Can a junior be on the service committee?
Yeah.
Yeah, that's the problem. So here this is A, this is B. They are not mutually exclusive. So P of A plus P of B minus P of A intersection B. What is that? Can you tell me quickly? Come on. So how many total sophomores are there? How many total sophomores are there?
12?
12. This one? 16, 10, 18. Right? Now what is the probability of A? What is the probability of being a junior? Quick, come on. See, probability, it's a fraction. What is it? Quick, junior.
Is it 16 over 46?
Yes, good job, guys. Then probability of B, being on a service committee. It goes on a row. Do you see? What is it?
Is it 5 over 15?
5 over 15. Now, why 5 over 15? Probability of a kid in the service committee. It can be a sophomore, junior, or a senior, right?
Oh,
Yeah, you need to be very careful. B means the kid is in the service committee. What is the probability?
is
15
it 16 over 46?
What is it? What is it, man? That's correct. What is it?
15 over 46.
15 over 46. How the 46 you got? How did you get the 46?
Because you add up like the total amount of students.
Good. You added the total number of students. Good job. So what is the intersection of both junior and in the service committee?
5 over 46.
Yes. Guys, to be honest with you, they will want to give you one question like this. Okay. It might be simpler than this, but they will ask you to confuse you, row, column, and stuff. A bivariate table might come, and they will ask for probability of not mutually exclusive events. Make sense? Okay, I'll stop here and I'll share the homework for this class with you. Okay, it will consist of only 4 parts, but definitely go through the PDF I gave you. Okay, now this insight should help you to go through the PDF I gave you very nicely. Makes sense? There is a lot of example problems in the PDF I gave you which will not match with this week's homework. So you have enough to practice. Please practice a lot of probability. Frisco ISD is famous for asking questions on probability. Okay, any questions? Any questions? Okay, I know.
Priya, so does that mean this Friday we don't have geometry class?
This Friday you don't have because we are on a break.
Okay.
Okay, yeah. For you, what is confusing? Ortho center. Okay, if you don't have any questions, you can log off, guys. I'll share the homework with you. Be it any questions, I'll share the mock test with you. You can try. Okay, I'll do it before tomorrow, please. Tomorrow night, give it to me. Okay. Any questions for me? I think I've provided insight into all the topics, but if there is any, just educate me. Come up with your final questions on the next Friday class. Make sense? Any other questions?
That is Priya.
Bye, guys.
Bye.
Yeah.
Yeah.
So for circles, do I have to? Because I don't think we completed like everything in circles, like
If you have a
secants.
few more, okay. That I'll
and
finish it next
stuff
class.
like that.
Next
Okay.
class. Is
Okay.
it okay for you? Can go over, right, Johan?
Yeah, I could do that too.
You can go over, but I will go over with my meaning just as a note, right, on the final day, on the
Yeah.
previous day of your class, and we missed out on a couple of part 10 and 9 I have not covered at all, right?
Yeah.
10 and 9 I'll do it next class.
Okay.
Makes sense. This was one bulk which I thought I did not cover. I really wanted you to give an insight before you go through.
Okay.
Okay, majority of the questions will be on mutually exclusive and dependent non-independent events.
Okay. Yeah.
Okay, but you'll have a lot of questions on dependent, independent, mutually exclusive, and not mutually exclusive.
Okay.
Geometric probability, you will have one question at least.
Okay. Yeah.
Makes sense? Yeah. And anything else that you came across?
So like we were doing today with like the factorials and everything, I was looking at something like that, but instead of like the factorials only, it was like permutation over a permutation and like a combination over a combination. And I mean, I think I get it more now. I might just need more practice with it, but I think I'm
Send questions to me, Johan. I'll help
Yeah.
you.
Okay.
You see what I mean?
Yeah.
Do more questions. Wherever you have doubts, send it to me. I'll help you.
Okay.
Make sense? Yeah. See, now the triangle problem. Choosing triangle quadrilateral was a combination by combination.
Mhm. Yeah.
Make sense? And one what we did was permutation by permutation.
Uh,
See, any probability question will be permutation by permutation or combination by combination. Anytime when they ask for probability, it will be either of these. Order only matters. Order doesn't matter. That only determines whether it is permutation combination. But numerator also will be combination. Denominator also will be combination, or the other way.
Okay.
Okay, but any question, anytime till your test, I'm happy to clear.
Yeah. Okay. Thank you. Bye.
I'll send you a couple of mock tests.
Okay.
Yes, Avi, what's up with you?
Things. So first of all, I just want to know how the CB exams usually work as, like how it works.
I think it's two separate chapters, two separate parts.
Oh, okay.
Okay, it depends on your ISD to separate it out, meaning some
Mm-hmm.
ISDs give it together, some ISDs separate it out.
Mm.
Okay. Um, have you come across this Texas Tech Part 1 and Part 2? Texas Tech CBE practice test. Yeah. Have you come across this? I don't know if you have come across, but this is something you can utilize. See, they will split it like this. Did you see? They'll split it as A and B. I don't know if they will combine or not.
Oh, okay. I never came across this, but like I got some papers on practicing it for.
You came across
Thank.
practice?
Yeah, I came across some UT practice papers on geometry.
Exactly. There also you'll have part 1, part 2. UT is okay. UT or Texas Tech, okay.
Mm-hmm. Okay.
There'll be samples, right? So that is split as
Yeah.
part A, part B, and the topics will also be separated out.
Okay.
Okay. Any other questions you have?
Yeah. Also, how do I, for permutations and combinations, I really get confused sometimes on whether I should
Not
use
attended.
this or that.
Class.
I did.
Okay, good.
That's why I came down with 10.
Thank you so much. I really appreciate it. Yeah, sorry, Abhi. Tell me.
No. So I just really get confused on whether I should use permutation or combination. But I find it very easy once I find out what I need to use.
Do one thing. I'm going to share some assignments with you, right?
Okay.
Work through that, okay? If you have
Mm,
questions, let me know.
sure.
Okay.
And finally, I'm sorry.
No problem. What is it? No.
Uh,
Any question that you have, I'm patient.
okay.
Hmm.
These centroid and orthocenter and all these altitude stuff, I get really confused on memorizing and knowing all those.
Okay, see, it's pretty easy if you remember this. Okay, hold
Yeah.
on. See here. One is just go with perpendicular bisectors. First, you go with
Mm,
perpendicular bisectors. Okay?
mhm,
With perpendicular bisectors, if you draw perpendicular bisectors, right,
mm,
you know, you will be able to draw if with the perpendicular bisectors, right? With the perpendicular bisectors, you see, one thing is this distance will be the same Avyut. Wherever
okay.
the perpendicular bisectors meet, it is called, why it is called the circumcenter, you know, because when you draw the red color perpendicular bisectors, you will get this circumcenter. You will draw a circle around the triangle. So it is called the circumcenter, and this is called the circumcircle. You got it?
Okay.
Whereas when you draw angle bisectors of a triangle, what are the angle bisectors? This is the angle bisector, right?
Mm.
You know what distance is the same? This distance will be the same. The other one will be
Okay.
the same.
Okay.
Okay, so you will
Yeah.
end up drawing the in circle. So this is called the in center.
Okay.
You got it?
Yeah. So when it comes to perpendicular bisectors, it's going to be the circumcenter.
Yeah, because you can
And
draw outside the circle only. And
okay.
this radius will be the same. Whatever is
Okay.
not the whatever is not the perpendicular bisector, that will be the same. Here, when you draw the angle bisectors and see, what will be the same? The other distance will be the same. So you can draw only an incircle.
Are they going to be like the perpendicular bisectors?
Yeah, meaning that will be the perpendicular to the vertex. Correct.
Okay. Got it.
You got it? So that's the way to remember these. When you come up with medians, right?
Mm.
The center point, that medians means middle point of the segment. That is why it's called the centroid. Median means,
Okay.
it itself means midpoints.
So is it going to be a 2x1
Yes, 2
or
is to 1, this one. Yes.
okay?
This is
The,
going to be 2 is to 1. This is going to be 2 is to 1.
so are these going to be the only ones they'll cover in the test?
Very, very on the surface. But this is quite
What do you
important.
mean?
This on the surface means, yeah, some concepts may be asked on this.
Okay, got it.
Okay, and 2 is to 1 ratio is important.
Ratio. Okay. Yeah. Yeah.
And what else is remaining? Perpendicular bisector. And what did I miss?
Earth to center.
Altitude. Yeah, altitude is orthocenter. Remember the word sounds the same. Altitude, orthocenter. You got it?
Okay.
Altitude means they're 90-degree things. So the meeting point is orthocenter. Make sense? Don't
Okay.
get confused at all. This is very easy. Circumcenter, incenter. Then median means midpoint, right? So that is why
Mm.
it's called the centroid. You see? Median, midpoint, centroid, center. You got it?
Okay.
Altitude, orthocenter sound the same.
Okay. Got it.
Anything else?
No.
Remember, altitude. See, the thing about here is sometimes altitude means the slope will be negative reciprocals of these two. You know about that, right?
What do you mean sometimes?
No, not some, every time. Meaning sometimes
Oh,
there will be
okay.
questions on that. So this and this will be negative reciprocal slopes.
Okay.
Make sense?
Yeah.
Okay.
And that time we can use trig ratios sometimes.
No, you have to use equations of circles from Algebra 1.
Okay.
To that level, they won't go in a geometry test. Don't worry about it.
Okay.
You got it? The equation of
Yeah.
this and the equation of this circle, this line, you know, right? They have negative reciprocal slopes.
Okay.
Okay. Now you understood, huh? Don't get confused at
Yeah.
all with these are the only 4 that are there.
Okay.
Make sense? Anything else you want?
No.
Any questions? Message me.
Sure.
Bye bye.
I couldn't get the access to it.
Just a request, ma.
Yeah, I requested.
I will send it. Spherical geometry. Harshita has asked. I'm going to send it to her. Avyukt has asked. Yes, ma. Any other questions, Avyukt?
No.
Okay, ma.
Yeah.
Okay.
Thank you. Enjoy your spring break.
Yes. Bye bye. You too. Bye.
You too. Bye.
Ma, I went against the computer. Ma, I went against the computer level 8 and I died.
You want to play chess?
Nah, not professionally. I just like playing.
Good night.
Good night.